excitement from something when people can get up here and look at this and say, I could probably put this together. You know, I can turn a wrench, I can bolt these things together, I can learn how to weld. It's not like when you look at the space shuttle and it's all this shock and awe of national pride, and it's not something that's approachable on an individual human level. But when people go up here and look at like vehicles we have on display that we've made over the past several years, you can look at that and say, I can learn how to lay fiberglass, or I can learn how to run a mill or something like that. It's approachable, it's possible, it brings it within the realm of something that people can say, I want to learn how to do this, and go ahead and do it.
It's rocket science, but as I tell people often, rocket science really is a bunch of individual sciences and things put together. It's not as intimidating or complex that way for people. In this case, obviously, both your team, the other teams competing in the NASA Centennial Challenges, and the folks around here certainly bring that down to earth a little bit more for people, no pun intended, obviously. Now, this vehicle, obviously designed to fly on Earth. Eventually, we hope to see vehicles like this taking off and landing on the moon. Of course, NASA, we're interested in that because we love to see the private sector do that, both to help us transport people more cost effectively, which is why we've invested in other commercial endeavors to try and have people fly people to the space station. We'd rather pay people to do that if they can do it less expensively than we can. We can move on to the bigger exploration stuff. That's why you guys are here, because you're part of that entrepreneurial spirit that's trying to go off and do that. So give me a little bit of sense of what it's been like to pull a team together of folks that frankly volunteer most of their time for you, right? But they're all sort of entrepreneurs in themselves, right? Entrepreneurs.
Yeah, we've got a really great team that I'm very proud of right now. And a lot of people ask me like why we don't have more classical aerospace engineers and so on the team. And the criteria that I looked for in the people when we brought the team together was people that were going out and doing things on their own, doing things to the best of their resources and ability. And the early crew was recruited from the high end of experimental rocketry, people that were building experimental rockets, experimental motors, level 2, level 3 certified AAA people, and stuff like that, where the people that had the urge and the desire, and I brought some more funding to it and some engineering direction to the whole project that let them go ahead and go in a direction that they wanted to go and use their abilities to the full extent there. And since then, the people that we brought on, like James, our more recent people, one of our more recent team members, I had been turning away volunteers for a long time because I honestly think that a small headcount is crucial for actually doing this effectively. If you bulk up too much, you'll just become ineffective. But when he...
That's true in a lot of things.
Yeah, and when he sent me in saying, well, I'm a welding instructor and I build all these things, and we're like, okay, that's just about perfect, come on down.
And from what I can tell, I'm not a weld inspector, but from what I can tell, he's done great work on the vehicles, and for him to build those things in like 2.5 weeks, he's assembled stuff, that's great. So briefly, again, while I get an indication here, we'll talk about the vehicle compared to the actual lunar landers, like the one that NASA took to the moon originally. In this case, your descent stage and your ascent stage are all one and the same.